Thank you for a nice introduction. So I will skip the introduction slide. And I think I can skip this slide as well, because I think you could hear it from Jirka. So we are part of this nice consortium of SADC. And yeah, let's start with the equipment we are running down in the basement of this building. People think that we are running mostly the AFM, bio-AFM instruments, but it's not all we do. We combine them with the other microscopies, with the other techniques, like for example, with the fluorescence confocal, and we will talk about it later. And with the microfluidics, which is becoming really like popular now, and with electrophysiology, for example. So yeah, I use this slide from a poster, so you don't recognize probably the images correctly, but we will show all the details later on the slides. So the core facility was established 2013. It's already 11 years. So this building wasn't built at that time. So we started in A4 building in the basement of A4 with two instruments. It's good to say that it was started by Peter Skladel, who is still running for a few last weeks the research group here. Then we somehow the research group was separated from the core facility, but still we are in close contact. However, we are more oriented on biosamples, not only on the sensors, and so trying to really face to the bioscience, regenerative medicine, and things like this for the living cells, which is sometimes complicated, but gives a nice scientific work for us. So the equipment, which was already somehow introduced, if we are like going from the large samples, the largest we can like characterize, we have these large systems from JPK. The one from 2014, I think, JPK Nanovizard 3. And now from the last year or 2 years, we have JPK Nanovizard 4. Now it's a part of Bruker. And we have some extensions to the Nanovizard 4, which is, for example, a nano indenter, which can be used for quite a routine characterization of the mechanical properties, like of soft samples, like from hydrogels, which are now very popular for culturing cells, and many applications like this, to the tissue slices, bone sections, whatever is needed. And we can also combine with this micro nanofluidics, which is called Cytosearch. It's a Swiss company which combines the microfluidics with the AFM instruments. So you can have like a nanopipette, for example, for your living cells, and so many other applications. For smaller samples, as was said, like really on a molecular scale, we have from Bruker. Now, most of the equipment we have comes from the Bruker, as it's like they are buying all the companies around. So we have this very popular Bruker Dimension FastScan for routine operations and really high resolution imaging. If people ask what is the resolution of your imaging, it's like, so we say like it's a DNA and the major minor groove you can recognize. And the advantage here, comparing to the other microscopies, that you can do it under the native conditions, like in buffered solutions. So you can change the buffer conditions, you can drive the temperature, whatever is needed. Then a multimode from Bruker as well, the most sold microscope AFM on the board in the size of a bottle of wine, as they say. It's not my idea, but quite a large bottle of wine. Then the combinations I was mentioning at the beginning, like for example, a very popular combination with the Raman microscope for the chemical characterization. So if you combine, you can see the structure, you can see the mechanics, adhesion, whatever, and the chemical composition, for example, and then some additional machines. And also traditionally from Peter Skladel, bioelectrochemistry, but we extend it now with cellular electrophysiology operations for cardiac and neuronal cells. So you can even get a more combination you can see the cardiac cells and you can follow the electrophysiological pattern with the, for example, mechanical beating pattern. I'm going to talk much about the science here. So yeah, what is the expertise? We briefly, like, because we need to define some kind of service. So we define basically like 11 basic services, from imaging of biomolecules, imaging of living cells, tissues, and so on, through the biomechanics, up to Raman microscopy, adhesion processes, falls, and so on, nanodepositioning, SPR biosensors, and very specific also scanning of upconversion nanoparticles, and so on. So maybe the point here, yeah, we don't talk about the science today, but there will be a user meeting on the last day of the November, so the November 30th, from 5 p.m. we organize, so you can come and discuss the science, discuss whatever you need. I will show you the invitation and the last slide. And yeah, so we don't have time for science, we have always time for some administration. So it was already mentioned here, if you are going to measure in all core facilities, not only in OR, but all of the core facilities, you should apply for the CISB project through this web page. But it's and then we somehow prove your concept. But it's always better idea first to contact me or my colleagues to discuss the project, and then you go and submit this proposal. So at the moment we are running 28 projects through this CISB interface, I would say. Well, you don't need to, and then if you don't apply for the CISB project, then you pay the full price. This allows you to pay only the 10% of the real cost. From the new year, it will be 15% because everything's going more expensive. So how it looks like, it's quite a short project proposal where you write the acronym name, your name, if you are a young researcher or student, then you write a contact to your supervisor, and then you describe your project, some background, and then you describe what your project is going to be about, what samples, what kind of technology are you going to use, and yeah. Anyway, we are still like scientific core facility, so the output of all measurements is a scientific publication according to the needs of all users. So we are running every year like 15 to 20 impacted publications. I mean, sometimes we are authors, sometimes we are not. But what we here calculate is the acknowledgement to the project, which is supporting us in our work. And yeah, because we cannot do for the users all the measurements, so we prefer to, if they help us or if they do the experiments on their own. So that's why we organize several workshops over the year. Sometimes the main workshop comes in the beginning of September, which takes 3 days, and this is quite like educational, with hands-on sessions, so the users can come and try the measurements under the supervision. For each instrument, we have some supervisor which leads the users. But during the year, we organize also a shorter workshop where we, for example, introduce the new technologies, the other companies which are also producing the technologies. So we are using or we would like to use in the future. So we discuss with users if it's a good idea to maybe obtain them in the future. So yeah, it was, for example, here in March, there was a short workshop where we discussed with users where we go next, like what to obtain in future. So yeah, there are several, even hundreds participants joining these workshops, and you're cordially invited to them. So as I mentioned, yeah, on the last of November, you can come and over the glass of wine, we can discuss the science. any other things like science, non-scientific, your plans, your wishes, and so on. So user survey, even we have like over 60 users every year, only like I think 6 users are filling the user survey, so I would maybe skip this. Mostly they are satisfied. I feel like on internet is the opposite. The people are like filling this user survey if they are not satisfied with the cell phones, with the cars and so on, but here you see mostly the friends. Yeah, we were trying to, the cooperation with industrial partners, we are not strong in this. So we tried to publish some like ideas with Nanobiotechnology, right? But no like real interest from the industry, I would say. So some drug testing, but still not probably the companies here, which would be interesting into this technology. Yeah. Here is the booking system. So the official way when you come to the core facility and you like to measure, you should book the time slot and do come to measure. But you know, especially with the living cells and things like this, it's difficult to book a time slot because sometimes they are not the cells are not maturating. Sometimes they are beating too much. Sometimes they are over maturated and so on. So anyway, it's good to discuss with us. Sometimes if you have just a nanoparticles, okay, you can measure it like anytime. But yeah, we are quite specialized on living cell cultures and so on. And it's difficult to really book a time slot, so, but can be used. Yeah, for data sharing, we use this medium storage, for example. So we motivate users to use this. It's fine for us. Yeah, was already mentioned, impacted publications still, well, it's quite outdated. We also keep like participating on application for grants, and yeah, 7 minutes on this. So here I used 4 slides which were published in March. Where we go next? So the wishes, and we don't know if it's like a good idea or not. So one idea was to maybe in the future to obtain a high-speed video rate AFM, where you can see fast processes. Yeah, you should see on this slide. Really, you can see, for example, molecular processes in real time. So this was special slide, special video for Robert Wacher. You can see in a real-time formation and pour in a phospholipidic bilayer. So that's what he is doing. So, and what we are imaging for him, so we see the final pores in bilayer. But with the high-speed video AFM, you can see the real-time formation, walking of the molecules, for example, and so on. But the price is €500,000, so it's quite one of the most expensive instruments in this area you can obtain. And not only for like fast imaging, but also for post-processing, like everybody is now doing the deconvolution of images, so you can go. This is like, if you see a molecule in AFM, if you post-process it, you can get the resolution which is like comparable to the crystallography, for example. You can denoise, you can use artificial intelligence, because you are able, with this machine, you are able to capture like hundreds, thousands images over a very short time. Advanced data processing, let's keep it for the user meeting on the last of November. Yeah, another equipment we would like to have is to have another laser for the Raman, because the Raman was obtained by Peter Skladal, and for the biological samples, it has quite with the laser wavelength, we have quite a huge fluorescence background, so it would be good to obtain another laser with a higher wavelength to don't have the fluorescence background in the samples. Yeah, and then we have the new Nanovisart 4 AFM with extended range of application, but the fluorescence we can combine with, it's a very basic. So we would like to go for some, for example, Leica thunder imaging system, which gives a better fluorescence images, and for the dimension FastScan. Yeah, it's also called FastScan, but it's really like FastScan. It's FastScan from 10 years or even years ago times. So with the new controller, we don't need to buy a new microscope, but we can go faster, but still not that fast. Yeah, okay, so, and I would really wish in the future, this is my wish, that all the measurements would finish with this, like, you know, from the users, that the user independently finish the experiment and so satisfied that he'll use the like the notice. Thank you for everything. And I'm leaving to Prague in this case. Okay, acknowledgement was several times mentioned here. Without the acknowledgement, without this grant support, we couldn't operate fully. You know, and if you like to inspect for more information, go to the web page. This is really all web pages was shortcutted to this version. So say that you and bio. Thank you for your attention. And as I mentioned, you are invited to the last November day to join us in the room 145, which is the one floor lower, and we will prepare for you a small glass of hot wine. Or even cold, if you like. Okay, thank you for
Nanotechnology and nanobiotechnology in general is one of the key sectors of the region. So no wonder that Jan has a lot to say to you. So if you have another question, there's time for just one, I think.
I have a question. Could you go back to the slide 22?
1, 2, 6, 5, 4. Oh.
So the previous one is the numbers. The previous one. This one, yeah, okay, 21. I'm sorry. Here you mentioned that you produced 15 to 20 impacted publications per year with CF acknowledgement.
Yes.
But at the beginning, on one of your slides, you showed that during the period 2019 to 23, you had 33 publications, which somehow doesn't correspond to the 15 to 20 per year. So could you explain the discrepancy?
1920 for 2 years.
Okay, I saw it.
I'm
sorry, I saw it 23. My mistake.
So it's roughly 1 year, and then we find another publication. So sometimes like that some users are using the acknowledgement without telling us, because when we are not co-authors, then we somehow find, oh, it's another acknowledgement. Yeah, but it's roughly 15 to 20 acknowledgements, really not co-authors. Especially last year, I see the users to be very, very sensitive to co-authoring. If we put the acknowledgement and you would like to be co-authors, I always tell them the acknowledgement needs to be there, otherwise you pay the 90%, right?
So I'm actually impressed with this nanofluidics device combined with the IFM. So how many users are there for this technology at the moment? And maybe can you briefly describe one of the use cases that you're running currently?
Yeah, we have just one user downstairs. And it's really, I mean, not many, because the spare parts, I mean, the cantilevers are very expensive. The company is like running only, because the instrument is not that expensive, but the cantilevers are enormously. For a single experiment, you pay like 500 euros at least, if you are well experienced. So you can, for example, aspirate to a single cell, or you can suck from a single cell the cytoskeleton, for example. So now there is a fellow from Giancarlo's group, and they will aspirate. They will collect the cytoskeleton from the specific cells. You know, they do the regenerative medicine, and it's very Usually people culture the a monolayer of cells, but they have a specific cells in the monolayer. So they will like really collect the cytoskeleton from the specific cells. Then they will collect the RNA, and through the reverse transcription, they will characterize the RNA difference between this specific cell and the rest in a single petri dish. So you can really, and so we told them, can you like separate the cells? Well, yes, but then it's not the same. So for these very specific like cases, you can also deliver some specific proteins in the cells, and they keep 95% of viability. So this is very sensitive, and very low amount can be like operated like inside or outside from the cell. For example, however, the first idea when we were obtaining this was more like robust, more like brutal. You can use like just a cantilever with a hole, and you can, for example, suck the cells and remove them from the specific, in fact, to study the adhesion of the cells on a specific material, like implants and things like this. But people are interested in here also. What we do by the scratching, which is like, quite like, not that nice method, like, but it's less expensive. Yeah. So, yeah. Again, we can like talk about it on a group meeting. So you are also invited.
Okay, thank you, Jan, for your presentation and your comments.